Kevin Kamps from Beyond Nuclear talks about how America's nuclear power plants are aging, and they're not aging well in many cases. This is alarming. Check it out. Leave your comments, ding the bell, share it with your friends, and subscribe to our channel. Kevin Kamps, the nuclear waste specialist over at beyondnuclear.org. And Kevin, we touched briefly on how nuclear power came to the United States, and you know, starting with the Manhattan Project and how the Price-Anderson Act. Nuclear power was so dangerous and continues to be so dangerous that there is literally not any insurance company in the world that is willing to insure a nuclear power plant. And so therefore, the federal government stepped in with the Price-Anderson Act and said, we will make the taxpayers the final insurers of the nuclear plants. So what are we getting for our money here? How many nuclear plants do we have in the United States? How many of them are the same designs as the one at Fukushima? That was taken out by a tsunami. Do we have to worry about that kind of thing here? Where are we at right now? What's the state of nuclear power in the United States?
I think of the 129 reactors that were built in this country, full-scale commercial reactors, there are still 94 operating at this time. So that means the difference have been permanently shut down, thankfully. But there are still 94. And of those, you asked about Fukushima's design. That's a General Electric boiling water reactor. And there are some dozens. There are a few dozen altogether that are either identical. There's about 20 of those. And then there's another 10 or so that are very similar in design. So that's about 30 of these Fukushima-style reactors here in the United States. They are located on the seacoasts, they are located on the Great Lakes, and yes, they are vulnerable to natural disasters, whether it be a tsunami, an earthquake, but also to tornadoes, to hurricanes. They're vulnerable to terrorist attack. They're vulnerable to accidents. I mean, 3 Mile Island, a different design, pressurized water reactor, had a meltdown because of a combination of design flaws and operator errors. And we have lots of 2/3 of our reactors in this country are pressurized water reactors. So there's tremendous potential for disasters. It's getting worse because the reactors are now dangerously age degraded. Some of the reactors are more than 50 years old. There's one in upstate New York that's more than 50 years old. And the Nuclear Regulatory Commission, which is, you know, in bed with the industry it's supposed to regulate, are fine. They're fine with allowing reactors to operate now, not just 40 years, but 60 years, 80 years. There's even talk of allowing reactors to operate for 100 years, which is a joke. I mean, the longest one has operated so far is just over 50. But they're actually considering allowing licensing to go out to 100 years.
Well, why is that problematic? I mean, I'm living in a house that's 50 years old, roughly. You know, it's still here. What is it about a nuclear reactor that age limits it?
Well, it's very extreme conditions and physical forces. It's the temperature. Reactors operate at something like 600 degrees Fahrenheit. There's tremendous radiation fields, gamma radiation, neutron radiation. Just one example, I'm speaking to you from my hometown of Kalamazoo, Michigan, and just 35 miles to the west of here is the Palisades atomic reactor that's approaching 50 years in age. And it happens to be the worst embrittled reactor pressure vessel in the United States. So this 8-inch thick steel that comprises the reactor pressure vessel and the nuclear fuel and the nuclear reaction is inside of that has been bathed with neutron radiation for 50 years. And it's now full of microscopic holes, essentially. It's like Swiss cheese because the neutrons have damaged the metal. And the danger is, if they ever have to activate their emergency core cooling system to heat down the core to prevent a meltdown, that could be the final straw for the reactor pressure vessel. It would be like a hot glass under cold water, but just imagine adding a ton of pressure per square inch to that hot glass. So you could fracture through wall the reactor pressure vessel, at which time there's no contingency. You would have a meltdown for sure if this were to occur. And the last line of defense would be the containment structure, and those are infinitely fallible.
Yeah. So the reason, my understanding of how Fukushima melted down goes something like this, and please correct me if I misunderstand this. Nuclear reactors produce heat. I mean, basically, it's just we're using radioactive materials to boil water, and then using that steam that comes from the boiling water to turn a generator, a turbine that produces the electricity that we all enjoy. First of all, I have that part right? We don't take radiation and convert it into electricity. We take the byproduct of radiation is heat, and the heat is turned into steam, and the steam spins the reactors, right?
Right.
Okay, so then there's this waste heat that has to be dispensed with, that has to be gotten rid of. And in the event of a crisis, in order to stop the nuclear reaction, to stop the production of heat, there's a whole set of carbon rods that get lowered down into the core that basically block pieces of the radioactive material from each other, so they can't interact with each other in a way that produces that fission and produces that heat. And am I right so far on that?
Right. You interrupt the chain reaction and shut the reaction down.
Right. Okay. So for a reason that I don't understand, when the nuclear reactors at Fukushima got hit with a tsunami, there was damage to the buildings. But the biggest thing that took them out was that there were diesel generators at ground level outside these buildings that were producing backup power for a nuclear reactor that was running the cooling system, and absent the cooling system, the nuclear reactors melted down. Do I have that right?
Right. So even though the reactors at Fukushima did shut down when the earthquake happened, you have to cool those reactor cores for several days before they reach what's called cold shutdown. And that's when they depended at first on the primary electric grid to run the safety and cooling systems. But the earthquake had largely damaged the grid. So they were thrown onto these emergency diesel generators to, force the cooling water through the cores to cool them. And that, an hour, 50 minutes after the earthquake, came the tsunami. And because of the bad location, the bad design of the diesel generators, they were taken out. And it turns out that essential pumps on the seacoast, as Arnie Gunderson of Fairwinds Engineering has pointed out, they were also taken out by the tsunami. So you had lost all cooling, primary cooling, emergency backup cooling, all cooling was lost. And it just took, in the case of Unit 1, it only took some hours before the core began to melt down. At Units 2 and 3, it took 3 days. But it was at that point a race against time. They were trying to introduce cooling, and they just couldn't. Everything had been destroyed.
So and the American reactors are more or less the same design. So if a tornado, and our tornadoes are getting worse and worse and worse, we're now having these things called derecos, these are mile-long, multi-mile-long tornadoes as a result of global warming. If a tornado takes out the power lines near a nuclear power plant, the nuclear power plant no longer has that backup cooling power, and then it tries to turn on its diesel generator, backup, cooling emergency power, and the diesel generators don't kick into action. If they haven't been tested recently or haven't been run, or the diesel fuel is full of gunk. Don't we have the same situation that happened at Fukushima?
Yeah, very much so. I mean, example, it was June of 1998, and a tornado scored a direct hit at the Davis-Besse atomic reactor near Toledo, Ohio, took out the grid. The grid was destroyed, and they were relying now on not 2 emergency diesels like they're supposed to have for redundancy. One was down for major repairs. They really just had the one. And they came precariously close to a meltdown situation. The one operating diesel kept breaking down. And so for 48 hours, they had to keep reviving it. And it was just a very near miss due to a tornado and dysfunctional emergency diesel generators. And Senator Markey has done a study. He's an important watchdog on the nuclear power industry in Congress. His study found something like 75 instances where emergency diesel generators did not operate when called upon.
Whoa. And so you don't need a tsunami with these kinds of nuclear reactors that we're using all over the United States to produce a Fukushima kind of event. Apparently we've just been very lucky, Kevin.
Yeah, I mean, I mentioned Davis-Besse, and I mentioned age-related degradation across the country, but incredibly at Davis-Besse, their containment could collapse and cause the accident. containments aren't supposed to cause accidents. That's how degraded it is.